Hello and welcome to this week's unit on what is pseudoscience. Well, let's define it. Pseudoscience is a theory, methodology, or practice that is considered to be without scientific foundation. It's a discipline or approach that pretends to be or has a close resemblance to science. And it's an activity that resembles science but is based on fallacious assumptions. So to define it, pseudoscience is a collection of beliefs or practices mistakenly regarded as being based on the scientific method. The prefix pseudo is taken from the Greek word for false, so pseudoscience is quite literally false science. As we've talked about previously, science is based solely within the natural world, meaning that every conclusion that a scientist will make must be based on something that can be tested in nature. Science can never use something from the supernatural realm as the basis or explanation for a theory. So some characteristics of pseudoscience. Is it unfalsifiable? Can it not be proven wrong? It makes vague or unobservable claims. Does it rely heavily on anecdotes or personal experiences and testimonies? Does it cherry pick, confirming evidence while ignoring or minimizing disconfirming evidence? So does it only select the stuff that it wants to select, that makes it look good? Number 4, does it use some sort of technobabble, words that sound scientific, but they don't really make any sense? Number 5, does it lack plausible mechanism? There's no way to explain it based on existing knowledge. Number 6, is it unchanging? Meaning, does it not self-correct or progress like the scientific theories do? Number 7, does it make extraordinary or exaggerated claims with insufficient evidence to back up those claims? Number 8, does it profess certainty, talks of proof with great confidence? Number 9, does it commit logical fallacies or arguments that contain errors in their reasoning? Number 10, does it lack peer review? It goes directly to the public and avoids any type of scrutiny from the scientific community. And number 11, claims there's a conspiracy to suppress their ideas. You can also use something called the baloney detection kit. It's a set of tools and skills that scientists use to evaluate new ideas, improve presentations, and strengthen scientific writing, or used to help identify bad arguments and construct better alternatives. And so our baloney test kit is a set of questions that you can ask. And so here are those questions. What is the reliability of the source? Does the source make similar claims? Have the claims been verified by someone else? Does the claim fit with the way the world works? Has anyone tried to disprove or falsify those claims? Where does the preponderance of evidence point? Where does most of the evidence lead? Is the claimant playing by the rules of science? Is the claimant providing positive evidence? Does the new theory account for as many phenomena as the old one did? And are there any personal beliefs or biases driving the claim? So let's look at some examples of pseudoscience. Cryptozoology, astrology and enneagrams, flat earth, homeopathy, telepathy and ESP, and the anti-vaccine movement are all just a few of the many types of pseudoscience. Here's 2 that you might have seen ads for, or who knows, you might have even participated in. Foot bath detoxes. They claim that your body is full of toxins and your feet are filled with special pores that when placed in a foot bath, they allow the toxins to leave your body. And so at 0 minutes, you start with this clear water bath, but after 30 minutes, it's this dark, orangey, rusty color. Here's what actually happens. The water is turning brown due to electrolysis. There are iron electrodes in those containers that rust, and that brown rust then goes into the water. So you're essentially leaving your feet in rust water. It has nothing to do with removing toxins from your body. Speaking of toxins, here's another way, those detox patches. They claim that you can put the patch on your foot and it will draw out toxins as shown in the brown sludge produced in the patch. So you've got that before and after picture there. Well, in all actuality, those patches contain a special type of acid that when that acid is moistened, it will turn into a brown mush and feel warm. So essentially, you sweat at night, your feet sweat a little bit, they release some water, and now you've got this sludge patch on your foot. Has nothing to do with it pulling out toxins. So let's explore myths in science, or common misconceptions that people might have related to science. The first is that the scientific method is a step-by-step process, or science as a whole is a step-by-step process. Science is fluid. It's unpredictable, complex. It involves a lot of people all working on different things in different orders, often all at the same time. And each scientist will use the scientific method in a way that best suits their needs and their research. Myth number 2, scientific models are visual representations of reality. Now, models are a great way to visualize a complex process that's taking place in science. So I'm sure at some point in your schooling you've seen models of the solar system or models of cells. However, most of those models, they can't incorporate all of the details of the complex natural phenomena that they're representing. Models are also not typically to scale, and they might not be a truly accurate visual representation of the concept that the model is representing. Number 3, science is a progressive accumulation of new facts. Science is constantly proving itself wrong. As new technology becomes available and more information is learned, the scientific community is able to discredit old theories it believed were true and replace them with newer theories that have more data and evidence to back them up. For example, at one point in history, scientists believed in what was called the theory of spontaneous generation, where living organisms could arise from non-living matter. After doing some experimentation, they realized that in fact was not true, and they replaced it with what's called the cell theory, which states that living things can only come from other living things. Myth number 4, disputes between scientists indicate that there is a problem with the scientific process. Debating is encouraged within the scientific community. It's important to question the conclusions of other scientists because it makes science as a whole a lot stronger. All scientific publications are going to undergo this peer review process as a way to make sure that the information shared with the world is as accurate as possible. Number 5, publication of findings is the endpoint of the scientific process. Just because a scientific paper gets published does not mean that it will hold the test of time or that publication is even correct. Scientists are encouraged to repeat experiments and build upon data and information collected in other experiments. For example, in 1998, a paper was published linking autism to vaccines. Since its publication, it's been retracted and proven incorrect. So there's a lot of false narratives in the world. And you as a teacher are going to experience those in your classrooms. And so my goal is to help you combat this false understanding, these misconceptions that students may have in your classrooms. And here's 6 ways that you can do that. You can encourage healthy skepticism. You can use case studies that have data. You can have students work in groups. You can use empathy. You can improve access to scientific literature and explore resources to improve critical thinking. So let's look at these in a little more detail. Encourage healthy skepticism. Healthy skepticism in science is the ability to use critical thinking to evaluate evidence and determine if an explanation makes sense. It involves being curious and open-minded while also withholding judgment until there is enough evidence to support a particular perspective. Healthy skepticism can help scientific achievement advance by challenging expectations and preventing biases. The second one was using case studies. A case study is a detailed study of a specific subject in a real-world context. In science, case studies can be small experiments or guided investigations that teach students about scientific topics using real-world data. Case studies can also be used to explore, describe, or explain a phenomenon in a particular time and place. Number 3, you can use group work. Group work can be effective in combating pseudoscience. For example, students can work in pairs to find examples of pseudoscience on campus. They can present their examples to the class and explain why they are pseudoscience and not real. Number 4, you can use empathy. Empathy can be a key tool in fighting pseudoscience. This involves understanding why people have pseudoscientific beliefs and helping them understand the scientific method. If you just tell them, you're wrong, you're an idiot, that's not helpful. If you take the time to understand why they believe the way they believe, and you value their reasoning and their input, and then help guide them to the correct information, they're much more likely to believe you. Number 5, improve access to scientific literature. Making scientific literature more accessible to the public through mainstream media and informal science education opportunities can help decrease the spread of pseudoscience. And number 6, you can explore resources to improve critical thinking. There are resources available to help students learn to evaluate pseudoscience and sketchy assertions. So you can use this floater terminology. Is it falsifiability, logic, objectivity, alternative explanations, tentative conclusions, evidence, repeatability? And so hopefully in this week, you're going to be able to do a couple different things. You're going to explore at some point an example of pseudoscience. If we were teaching this course in person, we would actually do one together. But since we are online, you get to kind of research one on your own. And if you want to test it out, you're more than welcome to. But there'll be some more information about that later in this unit. You also will probably have homework and some sort of discussion. But this concludes notes for this unit.